Hey guys, so this is problem number 3 and number 4. So just so you're aware, 3 through the end, so 3 through 7, all of the questions are going to be related to each other, and it's going to be critical that you guys are doing what that specific problem is asking for, okay? So for number 3, it says, if you roll a ball down a ramp and you find that the final speed at the bottom of the ramp is 1.1 meters per second, what's the ball's acceleration if it took 2 seconds to go down the ramp? So again, this one's pretty straightforward. We know that the equation for acceleration is equal to the final velocity minus the initial velocity over the change in time. Okay, and for change in time, you can use a number of different symbols, but we're just going to do a triangle. T, that means change in time. Okay, so if we set this up, we know that the final speed, it says at the bottom of the ramp, is 1.1 meters per second. Okay, so 1.1 meters per second. And I want you to pause and think about what's the initial speed. Well, it started at probably 0, right? Not probably, it started at 0. So 1.1 minus 0 meters per second, okay? Because that's the final velocity minus the initial velocity, because it started not rolling, and then you started and then let go and it started rolling. And then the change in time, the ball's acceleration, if it took 2 seconds. So it started at 0, it took 2 seconds to go down. Remember, change in, again, is the final time minus the initial time. So that's just going to be 2 seconds. Okay. So then if you do 1.1 divided by 2, and then remember, we are crossing out seconds. There's one on top. I'm sorry, we're not crossing out. There's one on top, one on bottom, so that's meters per second squared. It's going to be equals 0.55 meters per second squared, because there's one on top and one on the bottom, and we're not getting to cross these out, okay? All right, because this is really 1 over 1, so squared. So that would be the acceleration of the ball, okay? The final speed over the time that it took. All right, for number 4, it says, you want to find the acceleration of the ball after the ramp due to the friction on the floor. So we did something like this, right? So we had a ramp like this, and then the floor, and so you found the acceleration right here was 0.55 meters per second. Now we want to know eventually the acceleration of the ball after the ramp, okay? Because we all know that balls eventually slow down and stop after they roll on the floor, and that's due to friction, okay? But let's make sure we know what this question wants. It says you use Photogate. It doesn't really matter what Photogate is. All that Photogate is telling you is that it can capture the speed of the ball at 100 centimeters away. And Photogate captured the speed of the ball to be 2.88 kilometers per hour. Okay, so that is what you need to know out of all of that is the speed of the ball was 2.88 kilometers per hour. It says, what is the speed of the ball in meters per second? So that's all number 4 wants to know. So all this is a conversion question. Okay, that's all that this is. So we know we're starting at 2.88 kilometers per hour, and we want to get that into meters per second. So we have to set up the conversion table. So pause here, try to get it yourself, and then come back if you can't, all right? So I'm going to start this out as km, kilometers over hours. Okay, I'm going to set up my conversions. And I'm going to convert kilometers into meters first. Okay, so I know I'm going to put kilometers on the bottom because I want to get rid of that. And in 1 kilometer, there are, you guessed it, 1,000 meters. Okay. I really do need to get a mouse for this thing. Okay. So that gives me 2,880 meters per hour. See how I cross out the meters? Now we're in, or the kilometers, now we're in meters per hour. Now we got to get hours into seconds. Okay, so set up my conversion table. Hours are on the bottom. That means I need hours on the top. Okay, and in 1 hour, we have 60 minutes. But I'm not done there because I need to figure out seconds. So I'm going to do it again. And in 1 minute, there are 60 seconds. Okay, and now I should be able to, because I'm crossing out hours here, minutes here, and it'll leave me in seconds. So if I calculate that out, my answer should be 0.8 meters per second. 0.8 meters per second. Okay, and hopefully if you pause that, you got that as well. So you can stop here, and then there will be another video for the other few questions.